Okay, let's slowly start. Did you all have good lunch? Then it's perfect time for taking a nap because Power BI performance is a topic that's perfect for nap. I'm just kidding. Of course, I try to keep you as engaged as possible. So yeah, welcome to SQL Day from my side, and I hope you enjoy the conference so far. Before we start, huge thanks to all the sponsors that supported this event. You probably know that without their support, you probably won't be there today and tomorrow. So what I will kindly ask you to do during the breaks between the sessions, spend a few minutes, talk to them, and maybe you also find something useful. You'll probably find something useful there. So feel free to visit sponsor stands. One more thing before we start, short introduction about myself. My name is Nikola Ilic. I'm originally from Belgrade in Serbia. So you probably, most of you will understand me if I talk in Serbian. Serbian and Polish are very similar, which I found out. But for last 7 years, I live in beautiful city of Salzburg in Austria, where I work as an independent data platform consultant and trainer. Living in Salzburg was the reason why I've chosen this nickname Data Mozart. You probably all know that Salzburg is worldly famous as a birthplace of Mozart. So yeah, I was brave enough to use his last name as part of my nickname. You can find me on web. I'm trying to blog as much as possible at data-mozart.com. I'm also active on social media, so feel free to connect if you like. Other than that, I used to work for a long time with traditional Microsoft's business intelligence tech, so SQL Server, analysis services, integration services, reporting services, and more recently, if you consider the last 6 years, with Power BI. Privately, I'm father of 2 kids, and through football and Barca fun, I think you can conclude that looking at this photo when I was much younger, but I still love Barca. Okay, so before we start, I need to be honest with you. Creating a Power BI report may look like an easy task. So you import data, you create those nice shiny visuals, and your report is ready. So we can agree, I think, that creating a Power BI report is not a complex task. But one day you get a phone call from your user who is not that happy, I would say, based on this photo, and they complain that the report runs slow. Or what's even worse than that, your scary old DBA walks to your office and asks you to explain why your Power BI report burns all the available resources. So, as I already told you, creating Power BI report is not a rocket science, but there is a huge difference between the Power BI report that works and Power BI report that works efficiently. So we will now focus today on explaining how to build and design your Power BI reports to work in an efficient way. So I would say it's not a beginner session. I will not show you those beginner stuff, but once you build your dashboards, your reports, what can you do to make those reports run most effectively? And the first question, or the first thing for all of us who are having troubles with performance issues is, where do I start? That's a great question, and I'll explain why. Because once you identify what is the root problem of the performance in Power BI, you can then focus on trying to find a solution to this specific problem instead of wasting your time and energy or on some things that are maybe not so important. So where do I start? Always ask yourself, where do I start when I have a problem with Power BI performance? So I have to admit, I lied to you. It's not 7 deadly sins today. I use that as an analogy, of course, but we will cover 5 deadly sins in Power BI, or 5 areas that are most often responsible for bad performance in Power BI. First, we will talk about data model size. Then we will examine data refresh process in Power BI, how to optimize those 2, I like to call them background sins, so they are not visible to the end user. Then we will move to the front end, to user interface. We will examine a few basic examples how DAX calculations can cause slow performance. I will also show you how to reduce the visualization rendering time by applying some simple tricks. And finally, we will examine also how storage mode choice can affect the performance of your Power BI reports. So let's jump into the action. And first, we are going to talk about data model size. So we are starting with this point because it's so important that, for example, if you're operating on a pro license, so within the share capacity, there is a limit of 1 gigabyte per dataset. So it can easily happen that you reach that limit and you can't use the report anymore. So that's why it is important to understand. Also, from the perspective of premium capacity users, it's important because there are certain problems that data model size can cause. So let's examine how data model size can affect the performance of Power BI report. But before we do that, before I show you that in a demo, we need to spend a few minutes on some theory. So if you attended Alberto's session this morning, you probably heard him talking about VertiPack. So just to be clear, we are not talking about the import mode in Power BI. DirectQuery will come after. It will have its own 5 deserved minutes. So when you're using import mode in Power BI, what will happen? Power BI will launch the local instance of analysis services, and there is a storage which is called VertiPack. VertiPack is a columnar database. That means, to put it as simple as possible, that all your columns are stored separately, so physically isolated one from the other. And that's how Power BI stores the data when you're using import mode. The important thing to keep in mind when we are talking about import mode and about VertiPack database is that VertiPack keeps the snapshot of your data in memory. What does that mean? That means, for example, I imported data on my 9th at 2, let's say 2 p.m. And the latest data in my reports will be from 9th at 2 p.m. until I refresh this data set, until I refresh this snapshot, and I then have the latest data again. So you can imagine the main issue, let's say, with import mode is latency. You don't have always the latest data. That's important to keep in mind because we will come after to explain in one of the scenarios for using DirectQuery why this is a limitation of import mode. So there is a snapshot of your data in memory. And then depending on your business needs, you can refresh this snapshot from time to time. I don't know, every half an hour, once per day, once per month, and so on. So it's been periodically refreshed. Two main components of this architecture, of this VertiPack database, are two engines, Formula Engine and Storage Engine. So I'll not go deep into details, but it's important to understand because once you start optimizing your Power BI report, you need to know how this architecture works in the background. So those two storage engines, you can think of them, Formula Engine is basically a brain of Power BI. So once you write your DAX code, Formula Engine receives that query, translates this DAX to SQL if you're using DirectQuery. If not, it just goes and executes this DirectQuery, this DAX query, sorry. So Formula Engine is a brain. It's capable of understanding every user's request to do different calculations and so on. Once the Formula Engine generates the query and generates the execution plan, then Storage Engine jumps into the action. So you can think of Storage Engine as the muscles of Power BI. Why? Because it literally physically goes through the data which is stored in VertiPack database and pull the data from there and return it to Formula Engine to serve it in the report. So those two are most important components of Power BI architecture. I always like, when I'm talking about why data model size matters when it comes to Power BI, to give this analogy. This is a picture of the old attic. And now imagine that your task is to find, let's say, a book that you received from your grandfather when you were a kid. And what do you think? Is it easier to find it if your attic looks like this? Or if your attic is, like everything is stored it's in its own place. So it's easier to find the data when the things are compressed and put in the right place. Okay, so it's time for our first demo. I'll show you how data model size can impact the performance and how you can reduce the data model size by applying some very simple techniques. Okay, so I'm in Power BI Desktop and nothing fancy here, just a card visual that shows the total number of distinct date time values that I have in my chats table. Just let me know if it's visible for everyone. Should I zoom it a little bit or? I don't know if I can zoom it this one. Let's do it this way. Okay. So I have total number of values in my date TM start UTC column. I will show you how it looks like. So this is my date TM start UTC column, and there are almost 9 million distinct values in that column. I will show you this quickly in DAX Studio. How many of you heard about DAX Studio? Yeah, that's what I wanted to see. How many of you are using DAX Studio? How many of you are using DAX Studio every day? Okay, still good, yeah, thanks. Okay, so DAX Studio, for those of you who are maybe not aware, it's a fantastic free tool. It's created by Darren Gosbell, guy from Australia, and Marco and Alberto, and it has a lot of amazing features, probably deserves 60-minute session on its own. But one of my favorites is called Vertipack Analyzer. Once more, how many of you have heard about Vertipack Analyzer? Oh, guys, you're pros. Okay, thanks. So Vertipack Analyzer basically scans your data model and gives you, so it runs a series of dynamic management views against your tabular model and gives you information in a human-readable way about size of different objects within your data model, like tables, relationships, partitions, and so on. So you can access Vertipack Analyzer from DAX Studio. So I went to Advanced tab and I'll click on View Metrics. Let's expand this and zoom it a little bit more so you can all see what's happening here. So I have date TM start UTC column, which basically stores the data on a second level of precision. So I have date and I have hours, minutes, and seconds. And this value here, cardinality, does anyone know what does that mean? Yeah, yes, feel free to say it loud. Yes, number of unique values within the column. And as you can see, and to confirm what you've seen in Power BI report, we have 8.8 or almost 9 million distinct values. Now, as I told you, Vertipack Analyzer provides many useful information, and one of them is the size of the specific column. So you see that this size, the size of this column, all these numbers are in bytes, just to be clear. So the size of this specific column is 440 megabytes. So just one column is 440 megabytes. Now, people are lazy, and they are importing data without doing anything. So nevertheless, if they need to do analysis on a second level of precision or not, they will import data as it is. And I don't care, I have 9 million values, 440 megabytes, it's not my problem. But what happens if you need to analyze the data on a day level, which is, I would say, 95% of cases for analytical reports, a completely common request. So to have the numbers on a day level, not going lower than that. So what you can do, for example, and I'll go now to Power Query Editor. You see my date TM start UTC column. As I told you, it goes to the second level of precision. So if I just simply, of course, with assumption that there is no need to analyze the data on hour level, that's another story, but let's say on a day level. So what I can do, I can simply change the type of this data column. It's 3 clicks for approximately 5 seconds. I can change this to date. You see time portion disappeared. I'll hit close and apply, and let's wait for a few moments for Power BI just to apply those changes to our data model. It will take maybe 20-30 seconds. And then I'll go back to Vertipack Analyzer to show you the impact of these 3 clicks. Okay, there we go. And let's click again on View Metrics. I need to connect again. Okay, and let me expand my chats table this time and let me zoom it a little bit. You remember last time we had almost 9 million distinct values, 440 megabytes. Look at this now, we have slightly more than 1,000 distinct values, and our column is 6, or let's say 7 megabytes. So it's around 400, it's around 15% from where we started. So just by 3 clicks, we reduced the data model size like 85%. And my advice and my recommendation is don't be lazy, always check your data types, what you are importing into Power BI. Don't just blindly import data as it is. And of course, check with your users if it's okay to remove the time portion. If yes, you can make some really huge savings just by few clicks, as you've just witnessed. Okay, so let's, yeah.
But let's say you still need to have time, but then would it make sense to split one column that's data time into date and time, separate each column?
Yes, I will repeat the question. That's a great question. So the question was, if I still need a time for my reports, is it a solution to split date time column into 2 columns? One will contain date, the other will contain only time. Yes, that will reduce the cardinality, that will reduce the data model size, so you keep both things in your data model, but then you need to rewrite your measures. So that's the price you need to pay, because then you need to combine those 2 columns. Previously, you shouldn't care about that, but with that, you need to think about that. So if your data model size is not super large, I would suggest test splitting columns into date and times and see if you have to rewrite, I don't know, 300 measures and your data model is 100 megabytes, it's maybe not worth just that. But thanks, good question. Okay, so to wrap up this part about data model size with best practices, reduce the amount of data you are importing in Power BI. That means all the columns that are not necessary for data analysis, don't import them in Power BI. All of them consume the memory, and all of them make your Power BI data model bigger, slower. So think in advance what you need to import in Power BI. Reduce the column cardinality, as in our example. So cardinality is the enemy #1 for data model size, because the engine cannot compress data in optimal way when you have many distinct values. So whenever you can reduce the column cardinality, that will bring the biggest savings in terms of data model size. Then avoid using, this is not 100% complete, avoid using DAX calculated columns. That doesn't apply to Power Query because they're, simply said, they're not optimally compressed. So once the whole process of data compression is done, then DAX calculated columns come, it's their turn, so they're not optimally compressed. And disable auto date time. I guess all of you are aware of this feature in Power BI. In Power BI, what do I need to explain auto date time? Just quick short question. Do you all know what are the implications when you turn option auto date time on? Okay. Disable it. It will reduce the data model size. There are no hidden date tables in the background, and yes, always use a proper calendar table. Fine. So now that we optimized our data model size, our data refresh process will run fast and smoothly. It's true, but not in 100% of cases. We need to think about some additional things. So when we are talking about data refresh process, we are talking about the fact that we are not living in an ideal world. Because if we were to live in an ideal world, we would just take our data, put it in Power BI reports without any transformations, nothing. So everyone is happy and everything works fine. But unfortunately, that's not how things work in real life. So we need to do some kind of facelifting to our data. So to apply different types of transformations, currency conversion, to filter out some unnecessary data, do some aggregation, some calculations, and so on and so on. So where do we shape our data? Where do we prepare our data for Power BI report? The first, and I would say the most desirable choice is source database. So if you have a chance to model to shape your data on a data source side within the database, do it. You will see why very soon. So source database, you do all the things in accordance with traditional ETL processes, transform your data, prepare proper data types, everything else. If you don't do your transformation for whatever reason within the source database, the next station is Power Query. So Power Query, you all know probably, is a built-in tool within Power BI Desktop that enables you to perform all kinds of transformations to the data. So last time I checked in Microsoft's official documentation, more than 300 available transformations can be performed by using Power Query Editor. And what's the coolest thing, you don't need to know any coding. So it's, let's say, low code, no code solution for data transformation. But it comes with some considerations, let's put it that way. So if you use Power Query for data transformation, you need to be aware about the feature which is called query folding. How many of you heard about query folding? Okay, so let's say 50-50. So I will shortly explain what is a query folding. As you may, of course, you can also read from this slide, that's ability of Power Query's engine to generate a single SQL query that's going to be executed on the data source side. So all your clickings in the Power Query user interface, I want this filter out, I want to replace this value, I want to change this data type, I want to calculate absolute value of something. You click here and there, but what happens in the background, the engine generates the code for that. And that code in Power Query is being used with M language. And if the engine can't translate this M statement into a SQL, then we say that query faults. I will show you, one very basic example, and then it will be much easier to understand. But keep in mind, it needs to be a single SQL query that's generated by Power Query's engine. Okay, let's do a demo, and then we'll continue talking about that. Okay, so again, nothing fancy, one card visual. You see I'm using Contoso sample database online sales table, which has 12.6 million rows. So let's say that I'm a business user and I want to do some transformations to my data. So I'm in online sales filter table, and let's see what can be done. So I want to, for example, I need to pull some data from my customer table. So I'll take first name, last name, and gender. Okay. Here they are. Now let's say that I want all my first names to be uppercase. So I can just simply right click on this column, go to transform, and select uppercase. You see now all the first names are uppercase. Then let's say I want to change the type of my date key column. So instead of date time, I want it to be just date. So I'll switch from date time to date. You see time portion disappeared. Now let's do some filtering. For example, I will go to my total cost column, and I want to keep only those rows where total cost is greater than, let's say, 5. Okay, so you see all the steps are being recorded here on the right-hand side. Then, for example, I want to replace. Let's do a replacement. So for gender column, I'll right-click, replace values, and let's say instead of F, I want to see a female displayed in my report. Okay, and let's calculate, for example, absolute value. Where is my sales amount? Here it is. So I can now play around and do different things. For example, here I will calculate the absolute value. And finally, let's say that as a consumer of this report, I'm interested only to see the big orders. And big orders are all orders where sales amount is greater than something. Let's say when it's greater than 500. Okay, so we prepared our data, we shaped our data using Power Query Editor. And if I now right-click on the last transformation step, there is this View Native Query option here. When it's enabled, meaning when I can click on it, that means that my query falls. So my query will be executed on the data source side. In this case, it's SQL Server database. So I can click on it, and here is our nice little SQL query. It's not nice, I'm kidding. So yeah, especially if you're coming with SQL knowledge, that probably looks very ugly and suboptimal, but yeah, it's correct SQL. So everything you want in your Power BI report will be done on the SQL Server side. And let me show you. So you remember, for example, we transformed all the first names to uppercase. There is a tsql function upper to do this. We convert dates, date time to date. We replace in gender column F with female. We calculated the absolute value. So all fine, all our transformations were pushed to the data source. But that's not the most important thing. The most important thing in this SQL query is here at the bottom, this one. Why? Does anyone have idea?
Because it makes the where condition after all the transformation. So it does all this data.
Yes, it's down at the bottom, but it will be executed as one of the first operations. So when imagine that Power Query Engine and SQL Server, they are communicating, and Power Query tells SQL Server Engine, okay, I need some data for Power BI, and then SQL Server responds, okay, which data you need? And then, yeah.
We have a comment from the chat about the query folding. Sorry, that's
No problem, huh?
Query folding also works with some OData sources, not just SQL.
Yes, yes. So basically, that's correct statement. So it's not just SQL; it also works with some non-relational data sources. But I would say 95% of cases when we are talking about query folding, we are talking about SQL, some kind of SQL language. So either SQL Server, Oracle, or whatever. Yeah, thanks for that. So why is this important? So when they talk. And Power Query asks for data, SQL Server says what kind of data, and Power Query can say, okay, I want only those rows where sales amount is greater than 500. So what's going to happen is that SQL Server will filter out data in advance. So it will remove all the rows where sales amount is lower or equal to 500 and push only those rows where this condition is fulfilled. And let me show you the impact. So I'll click on close and apply. This number should change, and let's approximately see how long does it take. So
But we only apply SQL folding in Power Query Editor.
yes, yeah, only there, yeah. So we have like 1.5 million rows that satisfy all the criteria that we asked for. So that sales amount is greater than 500, total cost is greater than 5, and so on. And results were back in, let's say, 20-25 seconds approximately. Now let me show you what happens when you break the query folding. Of course, you shouldn't do that. This is just for the demo purposes, but don't break the fold. So this one, the step where I change the type of my date key column, I'll delete this one. And I'll do the similar thing, so I want to get rid of time portion, but now instead of changing type of my column, I'll choose transform and select date only. Yes, I'm sure that I want to insert another step. You see, the outcome is exactly the same. So again, we don't have hours, minutes, seconds here, so again, we have a date. But let's click now on the last step, and View Native Query option is disabled, so I can't click on it. Meaning there is no query folding for this step. If I go here, it's also grayed out. So I know that this is the step that broke the query folding, this one. But if I go here and click, there is a view native query. Yes?
There's another question from the chat. Have you worked with Power BI data marts in order to apply query folding for data sources that normally don't support it?
I can't talk much about data marts. I don't know anyone who use them on production. So it's still work in progress. So I don't have much experience with that. Sorry. Yeah. So if I now click on View Native Query, let's check our SQL code that's generated. Instead of having absolute, calculating absolute value, replacing F with female and so on, we just have this upper transformation here. And what's more important, there is nowhere close there. Okay? So let me show you what happens in this case. So I'll hit apply changes and let's wait again. So now we know that we should expect the same number. So this number shouldn't change. We know that it should be 1.5 million rows. Let's see how fast we can come to this. Oh, so what happened here? We know we expect 1.5 million rows. So why Power BI continue to load the data? Yeah, there is nowhere close. So SQL Server doesn't have idea that we want rows where sales amount is greater than 500. So what will happen? SQL Server will push all the data, all 12 million rows, and then Power Query will apply transformations over those 12 million rows. And you see how longer it takes. I don't need to tell you that it's more resource exhaustive and everything else. So that's the impact of breaking query folding. So always check if you expect certain transformation to have equivalent in SQL language, always check if your query folds or not. Trust me, from real life stories, some astonishing savings in data refresh process from 2 hours to 5 minutes and something like that. So depending on the complexity of data model, complexity of transformations, you see here it already took more than 1 minute and previously was 20 seconds. So let's wait just to confirm that, yeah, the number is exactly the same, but the performance is in order of magnitude like 6-7 times, 7 times worse. This is not something that your users will come and tell you, thank you very much, because they don't care, they don't have idea if data refresh process took 5 seconds or 5 hours. This will not affect their experience. But experience of your DBA will be severely affected if you break the fold. Okay, so wrapping up with best practices for data refresh process.
If you did it from scratch, would it be correct?
You mean if I did from scratch what?
The transformation, not change it after, but before as the final version. Would it work correctly?
No. So there is a step that breaks the query folding. So even if I started from scratch and I use the step that breaks the query folding, all subsequent steps will not fold. So
which one we should avoid?
Yeah, is it a solution for that?
Yeah. Yeah, that's a good question. The question is, how do we know what breaks query folding? Yeah, there is no. I cannot tell you.
I have no experience, but this looks like some kind of a bug.
No, it's not a bug. It's a bug. It's just that engine cannot translate it. It's just a feature. Yeah. So the engine cannot translate, for whatever reason, cannot translate certain transformations to SQL code, because what happens? Let me just quickly go back.
I think I would be able to do such queries myself.
Yes, but when you hand write your SQL code, then after that, if you need to do something in Power Query, there is no query folding. So writing native SQL query breaks the query folding. So either you do everything in SQL and then don't use Power Query afterwards, or you use Power Query but be careful with which transformations are breaking query folding.
Actually, there is a formula to enable query folding for native queries. This is something new, and I use it and it works. So actually, it works.
Which one?
It's like enable query folding. It's a formula.
Yeah. The function in Power Query. That's a good point. There is a function in Power Query value.native query, but it doesn't work always. So and not for all data sources.
Okay, I used it with Snowflake and
It works, yeah. It should work with SQL Server, but I heard that, for example, with Synapse, it doesn't work always. So it probably depends on the engine also, but yeah. Because we need to, query folding is also 60-minute topic, just query folding. But I want to show you the difference. Here, when I use this step that breaks the query folding, please pay attention to the formula here. Table.transform columns. That's the formula in M. And here, this one, table.transform columns. And for example, if I use the one that doesn't break query folding, so the regular one, change type and date, insert, it's table.transform column types. So this subtle difference between table.transform column types and table.transform columns, the one can be translated, the other cannot. Microsoft is changing this constantly. So maybe some of these things that I show you here in few months will not be valid anymore. So maybe they will find a solution that also this table.transform columns will also be translated to SQL. But there is no single resource where you can go and see which transformations will break query folding. There is no thing such that. So yeah, it's up to you to identify, and not for all the sources are the same rules apply like for value.native query. So yeah, it's an interesting topic, but there is no single point of truth to.
One more question: would changing the order, for example, filtering the values before the breaking step, help?
That's a great question. When I say that's a great question, that means the answer is on the next slide. So yeah, but thanks for asking. Thanks for asking. So best practices. First of all, I encourage you to go to Phil Seamark. He's a guy from Australia, New Zealand, who works for Microsoft. He has an amazing blog at dex.tips, and this one specifically, he offers you a free template that you can use to visualize the data refresh process. So you then can easily identify if you have, I don't know, 20 tables, which one is the bottleneck. So you don't need to go manually and check one by one. This is very good resource. Next, as I already said, whenever you can do your transformations and calculations on the data source side or as close to a data source as possible. One of the solutions, so if you need to apply some complex logic, transformation logic, and you have access to the database, you can create database views. So you can encapsulate all the logic within the view, and then you just import the view with already prepared transformations. That answers your question. Query folding is not all or nothing process. So if it happens that you have a query like this that folds up until 5th step, and then it breaks, and then all subsequent steps will not fold. Even if you have like filtering, which is always a step that folds, after you break the query folding, this will not be pushed to a data source side. So if you identify the step that breaks the query folding, move it down below. That also, I think, answers your question. So in this case, I will move it here, and then all previous steps will fold, and that one, if you need to keep it for whatever reason, the step that breaks the query folding, try to push it as much as possible down this transformation pipeline. I hope this answers the question. Thanks. Okay, so this is the golden rule for data refresh process. This is so-called famous Roch's maxim. Roch is Matthew Roch from Microsoft. Push transformations and calculations as upstream as possible and as downstream as necessary. I can't give you any better advice than this, so everything is encapsulated in one sentence. So stick with this and you're good to go. Okay, now we are slowly moving to user interface. And that's the area where users will quickly identify that there is some problem with performance. And you can expect some not so pleasant calls, I suppose. Okay, this is not obviously deep dive on DEX. Maybe you attended Alberto's workshop yesterday, but I want to show you in this session just a few examples that are very common in reality, where misunderstanding how to write DAX can lead you to a way that you wish to avoid. So what we can use DAX for: calculating unique customers, top selling products, running totals, and so on and so on. So we definitely need DAX in our Power BI reports. I didn't see any Power BI report without DAX formula. I would like to hear if anyone saw something like that. Yeah, that's what I thought. Okay, so the beauty of DAX, and I intentionally put this word beauty under double quotes, is that you can come to the same result in many different ways, and not every of these ways is the most efficient one. So sometimes, as you will see in a demo, little nuances can make a huge difference. And since this is a big demo, I suggest we start with it. Let me check the timings. Okay. Okay, so I will not apply this card. Okay, so again, I have just a table that shows me total number of big orders, those that are bigger than 500, for every single date. And I put it here just to be able to compare, because we will measure the performance of our DAX calculations in DAX Studio, just to compare the results. Because we are talking about performance, that's really important. But the most important thing is that you have accurate results in your reports. Performance without accuracy, yeah, it's useless. Okay, so let's go to DAX Studio, and this time I'm interested in different features of DAX Studio. And let me show you first this one, which is called Total Big Orders Bad. And I will explain why it is bad. Server timings, and I think we are good to go. I mean, you will realize why it's bad, because it's slow as hell. So while we are waiting, you see here, bottom right corner, you see elapsed time for executing this measure. It still runs. Let's wait for results. So it's super simple measure. I'm just calculating total number of unique orders. Here it is. Let's sort it. And I think, yeah, the numbers are the same as in Power BI report. That's good. But this measure took 30 seconds. So let's go to server timings and let's see what happens. Almost 31 seconds for executing this simple measure that should return the number of total unique orders for every single day. So what happened here is that I used filter function in inappropriate way. So what I did, I used filter function and I set the filter over the whole table. You heard this morning that's one of the greatest sins in Power BI, and it's one of the most common mistakes, especially when new users start using DAX. It's not a problem when you do this on a table which has 1,000 rows. You will not spot any difference between, I don't know, 200 milliseconds and 50 milliseconds. But in this case, it's almost 31 seconds. So basically what I'm doing here, I'm placing filter over whole fact table, online sales filter. And then I set my own filter to keep only those rows where sales amount is greater than 500. It's 30 seconds, and we have almost 1,100 storage engine queries. So for every single date, we have a separate query, a separate storage engine query running. Now, I guess you all know that this should not be so slow. So I will show you the first example how this measure can be written in an optimal way. This time is 52 milliseconds. And we have just one storage engine query. Okay, so the only difference, again, we have, let me zoom it a little bit, to be easier. Okay, the only difference between these two, again, we are using filter function, but here I'm using a single column. Basically, I just need to remove the filters from a single column, not from the whole table. I'm just interested in sales amount column. So what I'm doing here, I'm placing my filter on sales amount column from my fact table. I'm removing with all function, I'm removing all the active filters from this column, and then I set my own filter, which is the same as here, 500, and this runs, instead of 30 seconds, this runs in 50 milliseconds. This one is, as you see in the title, just a syntax sugar of the previous version. So the query plan, the execution time, everything is the same. The only difference is that you don't need to explicitly add, let me just put it this. So you don't need to explicitly add this combination of filter and all. The engine will work that way as well. But in the background, even if you don't write it, the engine implicitly adds this filter and all combination. So my suggestion, especially if you're working with some new users, always use this full syntax with filter and all, because this way everyone can understand what's happening. And final version with keep filters, that's a whole different function in DAX. We don't have time, unfortunately, now to talk about difference between keep filters and filter. But again, the same query plan, the same number of storage engine queries, just one, and 47 milliseconds. So we got, just to confirm, we got the same results as we had previously. So what's the moral of this story with DAX and one of the most common mistakes? If we have a question here.
I believe they are not equivalent. Values should be used instead of all for online sales filtered sales amount.
Yes, that's one of the additional options. So I decided to show this one, but yeah, in the end, as I said in the beginning, but good point. You can write your DAX in multiple different ways to get to exactly the same results. Not everyone is optimal. In this case, the main problem is putting a filter over the whole table. So whenever possible, put filters on specific column or just few columns instead of the whole table, especially if you're talking about giant fact tables. Okay, this one is also interesting. DAX is nice, but there are certain people who don't write DAX, so they're just interested why their visuals are rendering slow. And to analyze this, to identify what is the problem with visuals rendering in Power BI, there is a handy feature, Performance Analyzer, which is built in Power BI Desktop, and you can use it to quickly understand what is going on when you open the report page. And the rule of thumb is the more visuals you have on the report page, the longer time will be needed for rendering, because there are certain things that Performance Analyzer measures. Maybe I can quickly show you here. No filters. Okay, Performance Analyzer, start recording, and let's quickly refresh this one. In this case, I have just one visual on my report page, so it's only here. But this other value is interesting. DAX query and visual display, I think more or less it's self-explanatory, but this other is interesting. Does anyone know what this other means? Exactly. So the other means how this specific visual, in our case this table, had to wait for other elements on the report page to render before. So there is a queue of execution. Formula Engine is a single-threaded, works in a single-threaded way. So if you have 10 elements on the report page, it can't execute 10 queries at the same time. So there is there is a queue for those queries, and the last one have to wait for 9 previous elements to render before it can be handled. In this case, we have just one, but I will show you in one example how this looks in reality. So this other, try to reduce this value here. Of course, if you optimize DAX query that it runs in 32 milliseconds, that's it. I mean, you can't do anything with DAX here, but then you need to optimize the other. That's why it is important to reduce the number of visuals on the report page. So let me show you this example that I prepared. Here it is. So what I have, maybe it's a good idea just to start from scratch. So what I have here, I have 10 distinct card visuals. You can't see it all, but yeah. All of them are super simple. So just sum, average, min, max, and so on. No complex calculations, nothing. And I have 10 card visuals. And if I click refresh, let's sort them by total time, and let's sort them in descending order. So you see this card visual, this poor total sales quantity, DirectQuery is just 10 milliseconds. But the other is like 95% of the overall time of 220 milliseconds. Don't pay attention on milliseconds. This is very, very simple example. In reality, differences are much more obvious. So 208 milliseconds waiting for all the other elements to execute and to render. That's why it is important, what we were talking about previously. Now, if I go to another page that looks exactly the same, so what I did here, refresh visuals, and I spent around 15-20 minutes to build the same page using matrix visual. So instead of 5 card visuals, I have 1 matrix. If I click here, this is a matrix, nothing else than a matrix. With some formatting, with some playing around with formatting options, you can get to exactly the same result in much more optimal way. So instead of 5 queries, that for every card visual you have a separate query, instead of 5 queries, that's only 1 query happening here to populate the matrix visuals. Credits for original idea goes to Chris Hamill. He explained, and I'm not sure that link is included in the presentation, but if someone is interested, I can provide it later. How to mimic this exact same look of the horizontal card visuals and vertical. So with some formatting tricks, you can come to the same solution here. Okay, so what are the best practices if we are talking about visuals rendering? First and most important, reduce the number of visuals. Don't try to impress the users with, I don't know, some fancy icons, images, shapes, and so on. Each of these elements will take time to render. So even though if it's 30 milliseconds, if you have like 15 those elements, that's half of a second that you throw away. Those elements don't contain any data, any business value. If you want to use those kind of things like images, like shapes and text boxes and so on, you can use PowerPoint. So in PowerPoint, you design your perfect background, and then you just import this in Power BI and use this as a background of the Power BI report page. Reduce the number of DAX queries generated. So whenever you can to do that, instead of card visuals, use matrix like I show you here. Not always, obviously. This is not the solution for every situation like this. But whenever you can reduce the number of DAX queries, do this. Do this. The engine will thank you. If you're using visuals like tables, like matrices, Vertipack is really brilliant on a vertical level of scanning. So if you need to perform sum or average over certain column, Vertipack excels in that. But if you go to more detailed level of data, then Vertipack is not so strong. So drill through feature should be enabled whenever you need to display data on a more detailed level. Consider disabling cross-filtering. This is an option if you don't necessarily need mutual interaction between elements on the report page, disable cross-filtering. And sometimes also, if you have complex slicers and many report pages and you choose to synchronize all the slicers, that can also be sometimes issue for performance. And we are slowly wrapping up. I promised to talk a little bit about DirectQuery. I sincerely hope that you don't use DirectQuery in many situations because, yeah, it's not the optimal choice in Power BI. So first of all, what is a DirectQuery? That means that data, whenever you interact with the report, data is retrieved from the data source at the query time. And that means that data doesn't live in Power BI. Data lives outside of Power BI before, during, and after the query execution. So your query is just being pushed to data source and data comes directly from the data source. When we are talking about performance, DirectQuery will never improve performance of Power BI report. That's one of the biggest fallacies, so never ever. And speaking about that, there are only 3 situations that I recommend for using DirectQuery. First of all, when you have giant data, so you can't accommodate it in Power BI simply. So we are talking mostly about Pro license with Premium. I don't think if you enable large data set format that you will run into issues, but yeah, if your data is so large that you can't accommodate it in Power BI, you must use DirectQuery, that's obvious. Then real-time reporting requirements. So remember when we told that you have a snapshot of the data when you're using import mode, and then you refresh this snapshot from time to time. Now, if the business request is to have data with 2 minutes latency, you can't refresh data so frequently, so then you must use DirectQuery again. But here, don't fall into the trap. If you ask users what they need, they will tell you, I need everything and I need everything in real time. But that's not always the case. So talk to them and try to explain the downsides of using DirectQuery. So is it really necessary to have data with 2 minutes latency to analyze how many blue products we sold last year in Poland, for example? Obviously not. And the third reason is when security policies are applied on the data source side. For this scenario, you need also to keep in mind that single sign-on needs to be enabled. So report users' credentials will be propagated directly to the data source and all security policies will be applied there. That's the third valid reason for using DirectQuery. Best practices, I will just go quickly through this because we are running out of time. If you have permissions on the data source side, meaning on the database side, you can create indexes to support your most frequently running queries, ensure that data integrity is in place, and create persistent data objects like tables or materialized views where you can encapsulate all the logic before running Power BI queries. What not to do if you don't have permissions on the data source side. Avoid complex Power Query transformations. You saw the SQL code generated by Power Query engine. It's correct, but it's not probably the most optimal one. Also, complex DAX measures. Sometimes you will have very expensive SQL queries generated. Avoid relationship on GUIDs. GUID is a special type that exists in most of relational databases. Power BI doesn't support this data type, and during the query time, some implicit data conversions happening, and that slows down the performance. Limit parallelism and apply query reduction. That's something you can do from Power BI desktop. And check assume referential integrity option. This will generate inner joins instead of outer joins when DirectQuery is run. And in most cases, inner joins are more efficient than outer joins. General best practice regarding DirectQuery, avoid it. Yeah, so just those 3 cases where you must go this way. And now slowly wrapping up, this is not Monday to-do list, today is Tuesday, so it's Wednesday to-do list. So please keep this in mind when you go tomorrow and turn on your Power BI desktop. First and most important step, identify poor performing area or areas if there are many of them. When we talk about data model size, remove unnecessary data, reduce column cardinality. Then check if query folding is happening. If not, try to identify this step that breaks the query folding and move it down this transformation pipeline. Be mindful when writing DAX so you can achieve the same result in multiple different ways. Not every way is the best, so be mindful when writing DAX. Reduce the number of visuals on the page. Trust me, this is the low-hanging fruit and the easiest and quickest win that you can do to improve the performance of the report. And stay away from DirectQuery. So just use it when you have to go this way. Now, obviously, all of these are very important. That's why we are all here. But if you ask me to, maybe one of them is, I think, more important. And this, the first one. Why? I already mentioned at the beginning, but it doesn't hurt to repeat. Once you identify the poor performing area or the problem for your Power BI performance, you are then closer to finding a solution. You can focus on solving a specific problem instead of maybe DAX is not a problem. Then you don't need to spend time analyzing DAX. So identify the poor performing area and then focus on solving this specific problem. Any questions? I really apologize, we are 1 minute above time. You can also catch me around outside. No one fell asleep, that's good. After lunch, yeah, I was afraid. Yeah, then if there are no questions right now, thank you and DirectQuery. Did I?